Okay, we're going to be solving initial value problems, and maybe you've done these before, but this one right here slightly more challenging because we're going to be using exponential integration, use substitution, all sorts of stuff, and not to mention they're throwing in a logarithm here in this problem. So what we're going to do to solve the initial value problem is we have to do integration. Okay, and when you see that you are given an initial value problem, what is it that they're asking you for? They're asking you, in short, to solve for c, as in the plus c, if you will. When you add that constant of integration, you're looking for c, and so that's what's going on here. So they've given you an initial condition about the original function. All right, so at the end of this, we're not going to have c anymore. We're going to have what c equals. And so to do this, we must integrate. So let's go ahead and take a look. If I integrate e to the t times the sine of, let's see, what is it? E to the t minus 6 dt, okay? I'm going to have to do u substitution in order to integrate this. So let's pick this as u. And the reason why this one is really nice is because the du is already there, and you should probably see it already. If I take the derivative of u, I'm just going to get e to the t dt. And so I can put my ring around that. That right there represents my du, and I'm ready to integrate. So I end up with the sine of u du, and that right there is a very straightforward integral, isn't it? It's just going to be negative the cosine of u plus c, and that's the guy that we're looking for right there. All right, so we're going to back substitute now our u. We're going to have negative the cosine of e to the t minus 6, let's see, plus c. So this is our y, if you will, our function. And they tell us that in y, if we were to plug in the natural log of 6, we're going to get 0. So what does that look like? Negative the cosine of e to the natural log of 6 minus 6 plus c, some constant, equals 0. So we're going to see what this looks like. Well, e to the natural log of 6, that gets rid of itself right there. We're left with 6, right? And 6 minus 6 makes 4, 0. So all of this becomes 0. So we end up with negative the cosine of 0 plus c equals 0. Well, cosine of 0 is just, let me rewrite that real quick. I like to use my red pen. Cosine of 0 is just 1. So what do I have here? Negative 1 plus c equals 0. So what does c equal? C equals a positive 1. So I've solved for c. Nothing to it. So my final answer here, what is my equation? All right, what was that initial value? In other words, negative the cosine of e to the t minus 6 plus 1. And that right there is solving that initial value problem. All right, let's go ahead and take a look at another example. So that one was number 12. The next one we will call number 13. All right, so let's take a look at this one. This one's a little bit similar. dy dt we're given e to the negative t times the secant squared of pi e to the negative t. All right. And the initial value that they give us is that y of a negative natural log of 7 happens to be 2 over pi. All right, this one seems interesting enough. Let's see what we've got. We've got to integrate e to the minus t secant squared of pi e to the minus t dt. And I'm going to pick my u. Let's call that u right there. All right. So if that is u, pi e to the minus t, what do we get for du? Well, for sure we're going to have pi. We're going to have negative the pi, actually. E to the minus t dt. Just like that. Okay? So, I've got my e to the minus t dt. I'm missing a negative pi, so I'm going to make it happen. Negative pi, and I'm going to, by consequence, write negative 1 over pi on the outside here. And let's see, I'm going to ring my du now that I'm ready. There it is, du. And let's rewrite. Negative 1 over pi, the integral of secant squared of u du. And this one is another one of those straightforward integrals. It's just tangent. Okay, integral of secant squared is tangent. So the tangent of u plus c. And now we can back substitute. Negative 1 over pi, and then u, of course, tangent, and then the u was pi e to the minus t plus c. Okay? And so yet again, we plug in what we know. Well, we know from the very beginning that if we plug in the negative natural log of 7, we're going to get 2 over pi. So let's see what that looks like. Negative 1 over pi, tangent, and I'm going to have pi e to the negative natural log of 7, all plus c. Well, this e to the natural log gets rid of itself, right? Okay, and let's see. Oh, I'm missing the negative. I knew I was missing something. It's a negative of negative natural log. So that right there is positive in itself. So the e in the natural log gets rid of itself. What do we have? We have negative 1 over pi, tangent of, it looks like 7 pi, plus c. Well, if you know anything about the tangent of pi, okay? Oh, by the way, this equals 2 over pi from the very beginning. If you know anything about the tangent of 7 pi in this case, which is, I believe, coterminal with the pi, tangent of 7 pi there is 0. So this whole thing is 0. Multiplied by this makes all of this 0. 0 plus c equal 2 over pi. That's what we've got there. So we found our c value. C is 2 over pi. And so our initial equation that we found here is that we have the tangent of, or the negative tangent, I should say, pi e to the minus t, right? And I'm going to say plus 2, and it's all divided by pi, because if you look back over here, it was 1 over pi, 2 over pi. You can write it all over pi. It's nothing to worry about here. So if you didn't quite catch that, go back, pause it, figure that out. But this right here is the solution. All right, the equation. All right, and I think we've got time for one last example. All right, this next one's kind of nice as well. We'll call this one, I believe it's number 14. All right, what do we know about number 14? We know that dy dx is e to the 4x cosine of e to the 4x. All right, and the initial condition is that when you plug in 0, you get 0. So now we integrate. All right, let's see what that looks like for us. All right, we're going to say this is u. So u equals e to the 4x, making du 4e to the 4x. Let me make that x a little bit smaller, and then dx. And so we've got that in play there. What else do we need to do? Well, we are missing a 4, so I can make that 4 happen, but by consequence, I need a 1/4 on the outside. And so I've got my u ready, and I've got my du, and now I'm ready to integrate with substitution. 1/4 the integral of the cosine of u du. Again, another straightforward integral, which gives me 1/4 of the sine of u. Oops, I'm jumping the gun there. Plus c, which is 1/4 of the sine of e to the 4x. Plus c. Okay, so 1/4 of, well, let's backtrack here for a second. I know that when I plug in 0, I'm going to get 0. So let's take a look. 1/4 of the sine of e to the 4 times 0 plus c should equal 0. So what does that look like? 1/4 the sine. This becomes e to the 0. And what's e to the 0? E to the 0 is 1. So sine of 1 plus c equal 0. And there's really nothing to it. I mean, you could find the sine of 1, but you're going to get some like weird looking decimal surely. So all you have to do is move that to the other side, and that is to say that c is actually going to equal negative 1/4 sine of 1. Okay, and we're going to leave it like that. Now that we know what that is, we're just going to substitute right there. And that is to say that y equal 1/4 the sine of e to the 4x minus 1/4 the sine of 1. Okay, and really nothing to it. All right, so these problems are really nice, these initial value problems. There's actually a branch of calculus, a branch of mathematics called differential equations that obsesses about solving these types of problems, these initial value problems. So if you're interested, you know, after a Calculus 1, Calculus 2 course, you can definitely take a course in differential equations and expand your mathematical horizons there. But as always, I hope this video was helpful. And remember, like and subscribe.